Hello guys, welcome back. Before starting the video, I want to tell you why you need to watch this video or what you will get after watching this video. If you watch this video, then you can understand how to use different models for binary classification, like linear logistic regression model, how to use, and decision tree and KNN model, how to use them, how to train them, and how to use them. And you will also learn classification of model. You have these three models, right? For this demo, I'm taking these three models, and we also classify these all models, and we evaluate which model is performing better. And this evaluation is already all related to supervised ML classification based models. In ML, we have supervised models and unsupervised models and reinforcement related models are there. In supervised also, we have two types of models, that is classification based models are there and regression based models are there. In this video, you will understood for classification based models under supervised ML models, how can you able to evaluate them, so that you will understood, as well as how to use these type of models like logistic regression based models or decision tree models or KNN models in real time. For this demo, you can use your own laptop and you can use your Jupyter notebook. You can directly install Jupyter notebook and use the Jupyter notebook there. Currently, for this demo, I am using some cloud related Jupyter notebook that is provided from Amazon SageMaker AI. You can see under this notebooks, I created a notebook instance and I clicked on this Open Jupyter Lab. Then it will open me a Jupyter notebook. For your practice, you don't need an AWS account for creating that Jupyter Lab notebook. You can just move on with a Kaggle notebook, where Kaggle is providing you free notebooks, Jupyter notebooks. There you can see, you can click on this new notebook so that it will create some sample notebook for you. There we can able to write the code and run the code for free. You can see I'm just running it. So like that, you can write your code here and run that code as for free for now. For this demo, you can practice like this in Kaggle notebook as well. For this, even you don't need to sign in as well, and you can directly use the notebooks from Kaggle and you can implement your practice in online. If you not have any platform or you not have any environment ready setup with you in local systems. For this demo, I have two tasks. One is this binary classification. Then I need to do this model evaluation as well. To do this binary classification, what I require? I generally require some data set to do the binary classification or to use ML models for binary classification. So for this demo, I'm using this Titanic data set, titanic.csv. It is freely available in Google, or you can open it, or this is freely available in Kaggle notebooks as well. You can use it there as well. This I have downloaded it from Kaggle and I'm using this right now for this demo. I'm providing the path of this file. I want to copy the path of where I store this file. I copied the path and I'm closing this. Now I want to use the path to load that data set. So I'm taking a variable with the name path, and within double quotes I'm storing the data. Since this is a CSV file, in order to load CSV files, you need to import pandas. I'm using this pandas library from Python to import this CSV file, to read this CSV file. I'm importing pandas as a PD. So whenever I require pandas, I'm using this shortcut, that is PD. So first I want to read this file, right? Yes. To read this file, pd.read CSV. So this is the function that you use to read the file, and I'm providing the variable that is path and storing the value in this data variable, so that this file will be read and stored in this data variable. You can even see the top 10 records of this data by using head. By using head command, you can able to see top 10 records after reading this data using pandas data frame. I'm just running it by just clicking on shift and enter. If you click on shift and enter, you can see one cell is running. Wait for a moment so that this data will be loaded into this variable. Okay, in the current location. So in that path, this data is there. Okay, you can see. Now we get this data. Now I just loaded my CSV file into this data variable and I just printed only 10 elements from it. Now what I want to do. So this is related to this task. Like I want to do binary classification at first. So to do binary classification with ML models, this data I want to do binary classification. So that is, I want to check whether a person can able to survive or not. Before doing that checking, I also expecting one more point, that is let's put it top and do this task later. I want to check how many fields are empty. So to check how many fields are empty, like null, or I want to see the missing data. I want to see the missing data present in this data in this CSV file. To see the missing data, you just write the command data dot is na dot sum. It will provide you in order in this data set for each and every row how many data records are missing. Under age, I have 177 records are missing, and in this cabin I have these many columns or records are missing. In this embark, 2 values are missing. And if you want to see the description of it, so just write that data dot describe. It will describe you all the details, like what is the maximum value in this passenger, what is the maximum value in this row, count, mean, standard deviation, minimum, 25%, 30%, or 50% and 75% of the data. So these all will be shown here under this describe. Let's say I want to see the shape of the data, like how many, like I want to see how many records are there, like how many rows are there, how many rows of data are there, nothing but how many records are there, passengers records are there, and how many features, nothing but 12. This 12 represents columns or features. It will provide me two things, rows and columns. What does this rows represent? These rows are nothing but records, and these columns will represent features. Okay, so in this way you can able to check the features of the data, and let's say these are the length of records and these are the features of the data. Now let's move back. If we see here, like if we see age, totally 177 records are empty, like null values are there. I want to fill that data. I want to fill the data with some value. So how can you able to do that? If you want to fill the data with some value, then you need to consider like with what data you need to fill there, so that the overall performance of your model will not change, or the output accuracy will improve. That is, the output accuracy will not degrade. So for this, for age, if we consider the age, if we take the mean value, then obviously the resultant after calculating the whole result will not be changed, right? Yes. So first I want to calculate the mean of this age, and I want to use that for the all the missing data. So data of age will provide me that age record values, and dot mean. This function will actually provide me the mean of the whole data present in this records. Now what I want to do, I want to use this data for what are the data which is not present in the age. What are the fields or what are the records where the data is not available. So data of age dot fill all the not available column values or not available records with this data, and assign that to data of this age row. Then at last we'll also see the total number of null values. Previously the total number of null values, how many? 177. Now let's see how many null values are there. Dot if not available dot sum. It will provide me the total number of null values. You can see now 0 null values are there. That is at not a number value or null value place. At here the mean value, whatever the mean value that we calculated, that we stored. So that's why here we fill that missing data. What is this? Filling missing data. And what is this? This is nothing but analyzing dimension, or you can say the shape of data. And so this also we can able to perform by using a null, null. Okay. So by using null also we can able to calculate how many values are null in this row. Okay, in this way we filled this age row. Okay, this is fixed, like in this age column. So the null values will be, there are no null values. You can now see there is a data dot is not available dot sum. It will provide you overall dot data related null values. For the age, currently null values are 0, so no issue is there. And if you observe the sex column, here we can able to see male as well as female. That means the multiple categories are there. I want to categorize them into a single, like a single value. If you want to categorize them into a single value, pandas dot get dummies option is there, and so there you need to provide for what category you want to use this dummies or generate the dummies for this. What is this? For this column, that is sex. So I'm providing that column exactly. Now it will generate me the dummies for this column, and I'm taking one more, or I'm adding one more column, that is a male column, to this data, already available data, and there I'm storing this dummies data, and I'm just dropping the first value because it generates me two values. What are the two values? Is it will generate me first male data, like if the person is male, then it will provide me for that row once, and for the females it will provide me 0. In the second time it will provide me the female related records, like whenever male is there it will provide the 0, and if there is a female then it will provide 1. So like that 2 rows will be provided. Now I'm just taking only one row and I want to see that data. This is all comes under data processing stage. You can see. Now I want to see, for more clarity, I want to see two columns, like the gender as well as the male or not. So male, yeah, it's true, and female, it's false. So like that, we'll get the data now. If we see the whole data, how our data will be now. You can see this is how our data will be. If a person is a male, then it will be 1. If a person is female, then it will be 0. So in place of sex, we will use this male row in while loading our data to our models. Now let's take the inputs, like let's create, or let's consider only the required dataset. I want to predict it. This is the Titanic dataset. It will tell me whoever persons are survived and whoever persons are not survived based on this data. Now, so what is my output is I want to check at last whoever are survived or whoever are not survived. So that's why I'm taking y, nothing but output as this survived data. So check with the spelling. If there will be any mistake, then we'll definitely get some error, like the row is not there. And the x data, nothing but based on what data you are predicting this y value. I'm taking the values, so it's not a single value, so that's why I'm taking a list of list. So based on multiple columns, I'm identifying this. Based on this column, that is this male, like based on the sex, I'm considering this. I'm considering this column, as well as I'm expecting to consider this column as well, and I'm expecting to consider this age column as well, and I want to consider few other columns like passenger class, that is this P class, P CLASS. Okay, then I want to consider at last this column as well. Okay, so now I taken both the input as well as the output. I want to prepare this for loading to my ML model. I want to split, or I want to take this data set for both training and testing. So first I want to split the data set. I have this data set of input as well as output. You can see this, like how the data will be. So this is the y values and these are the x values. Now I want to just split the data set for training as well as testing, so that I can use the data for testing, separate data for testing and separate data for training. to split the data that I have into two data sets like train and test data sets. To split like this, we have already some available library present in, we have already a method available, that is train test split. This method is already available in sklearn from sklearn.model selection. So this is already available, so that I'm importing from there. Now I want to split my x and y values, so that's why to this train test and split function I'm passing this input as well as output, that is expected output, and input features and expected output or target I'm providing. You can also provide some more features like what is the test data size by providing the percentage like 0.2. Currently I'm not providing because it will consider some value by default, and it will provide us the result like for this training for these features it will provide me the train values at first, then test values, and for the output also it will provide me the train values after splitting, and the test values after splitting it will provide me. So at the end I want to check whether it can able to split correctly or not, or at the end I want to see the result, like I want to see the output whether it successfully splitted or not. For that I'm just printing this y test data. After this I want to see the train data as well. Okay, you can see it was splitted successfully, and the tested data records are totally 223 length, and the training data length of records are totally 668. Previously totally 891 rows are there. Among that, for testing these many records are considered, for training these many records are considered. You can able to fix that by providing some test ratio here, like 0.2, 20% I want to use for testing, so like that you can able to specify here. Now I splitted my data set into two parts, so based on my consideration. Now I want to use this training and testing data for creating my binary classification related ML models. So what type of ML models now I am creating? So as we mentioned, these type of binary classification models are now we are going to create. What are they? First I want to create linear regression based model. Linear regression based model. So where it is present? It is also present in a sklearn.linear model. You need to import this linear regression, and I'm storing this in this LR variable. So now we just taken the algorithm and store in this variable. Then I want to train this. Let's print LR to see the linear spelling is wrong. Okay. Now our model gets loaded. Just our algorithm gets loaded into this variable. Now I want to train this. To train this, just use the command that is lr.split fit of the input data. So what is the input training data? X train. What is the output training data you are expecting from this input? Y train. And so I'm just fitting it and storing it in lr underscore h for thinking it as a history. And at last I'm just printing this, or I'm just running this so that LR will be displayed. Now our model color will be changed. That is after training you can observe clearly the color will be changed. And yeah, now so in this way you can able to create your linear regression based models. Let's say you want to create this decision tree. So I want to show you how to create a decision tree based model as well and train that model as well. For that sklearn.tree, you need to import decision tree classifier. So we can use this classifier, decision tree classifier, for binary classification, and decision tree classifier DTC. In short, I'm storing in this variable, and this algorithm I'm loading into this variable decision tree classifier. Then I want to train this by using fit method with this train data and with this train target, and store it in this history variable. And in the same way I'm just printing this decision tree classifier. In this way you can able to load the decision tree algorithm and train that algorithm, and you can able to create your actual ML model. Now at last I want to show you how to create this KNN model as well for binary classification. So this also you need to import from sklearn.neighbors. You need to import this k neighbors classifier. You need to import this k neighbors classifier. So cannot import this name from here. Okay, I think the mistake in this classifier spelling. So let's rerun it. I'm just entering the shift and I'm just pressing shift and enter so that this was running. Okay, currently no errors are displaying. So in this way, you can even import this k neighbors classifier, and you can load that algorithm into this KNC variable k neighbors classifier algorithm. I'm loading into this KNC in short, and I want to train this KNC algorithm as well. So for that KNC.fit of, so what is your training features and what are your expecting training output? So that I'm providing, and simply I'm storing in this KNC history, and I'm now printing this KNC, that is a k nearest neighbors classifier. Okay, now my three models are readily available. After training, my models are now available. We taken the models and we loaded our algorithms into variables, and we trained with the training data. Now I want to do, so this is the first task, that is a binary classification models using ML models like linear regression based models and this KNN based models, and we have seen this. Now at last we just need to evaluate these models. So based on the testing data that we have, we have already split the data set into training as well as testing. Now we have already created the binary classification models like a linear regression based model we created, decision tree classifier we created, and k neighbors classifier also we created, KNN based model. Then after creating these models and training these models, we just need to see which model is performing good, and we'll prefer that for our real-time implementation. So to see that or to check which model is best, we need to do this evaluation. So what is that? We need to do this evaluation. Now we'll see how to do this evaluation, model evaluation. Now let's have a question, that is how to evaluate these classification based models. So what is this classification? Under which type of ML models these classification models will come? These classification models will comes under supervised ML models, supervised type of ML models. In ML models, we have three types of ML models are there. One is supervised, and second one is unsupervised, and third one is reinforcement type ML models. Whereas these classification models comes under supervised models. In supervised, we have again two classes, that is the classification based models and regression based models are there. Now, since we are evaluating, we want to evaluate these classification based models. So what are the options that we have? Since we are just classifying the data among the categories, we'll identify the accuracy score. So based on that, we can say this model is performing this much good. So how we are finding this accuracy? Based on true positives and true negatives. What are the true positives it is identifying and true negatives it is identifying over a whole data set? Based on that correct prediction, we'll identify the model related accuracy. Let's say I want to see the whole data like true positives, like correctly predicting positive values and correctly predicting negative values I want to see. And I'm expecting to see the wrongly predicted values like false positives. Even though it is false, but it is predicting positively. That is, even though the result is wrong, it is predicting correctly. So those type of records also I want to see. Like incorrect records also I want to see. How can I able to see that? So those you can able to see by using confusion matrix. By using confusion matrix, we can able to see that data as well. And if we want to see the total contribution of positive values or true positives or true negatives, like we can say receiver operation characteristics. Let's say if we want to see receiver operating characteristics, then we can also see that receiver operating characteristics. By using this, we can able to identify the graph, and we can see the accuracy or receiver operating characteristics as well. So this graph is actually present in between 0 to 1 for each and every model. This 0 represents less accurate, and this 1 represents high receiver operating characteristics. That model is performing very good. That type of model is best fit for our requirement. Now let's see the accuracy, or let's see how to do these three things. How to evaluate these three things for our 3 ML models, what we have just created. So for this, the matrix already available in sklearn dot matrix. I'm just importing this accuracy score, and I want to use this accuracy score. So I'm just running this to see if there is any error. I want to see this accuracy score for my each and every model. I'm taking my 3 ML models. Like first, what is the ML model? That is linear regression LR. I just taken this in a list, and I'm taking this decision tree classifier as well into the list, and I'm taking this K nearest neighbors classifier, that is KNC, as well into this list, and I'm taking each and every model from these 3, and let's print each and every model so that we can see the model. Okay. For each model in this list, I'm printing. So first one is linear regression, second one is decision tree classifier, and KNN. Now their accuracy I want to see. So to see that accuracy, by using accuracy score, we can able to see that. To see the accuracy score, we need to provide 2 things. One is the predicted output. How can we able to get the predicted output from the model? We just need to pass the test data. So this is the testing, right? During this testing phase, I want to pass my test data. So test data of input features I'm passing to this model. So by using the predict function, I'm just passing the test data to my model to get the predictions, output predictions. To find the accuracy score between the predicted as well as the actual output. So what is the actual output? Y test. You can see Y test is the actual output for this testing input. I'm just passing the predicted value as well as I'm passing the test, that is the actual value, to print the accuracy by using this accuracy score matrix from this sklearn for these 3 models. So what's the mistake that we get? So can't able to fix mix of continuous binary targets. So let's see. We predicted the, or let's print the predicted value. Y predicted Y test. So let's see the error. What I'm getting, the error that I'm getting is this. That is, so binary, like classification matrix can't handle mix of binary and continuous targets. Actually, we provided both binary targets only, but why it is showing like that? So let's see the output or what it is predicting, what our models are predicting. So I'm just printing that predicting values as well. The first model, that is linear regression model, is predicting. Okay, here the binary values, these are not floating point values are predicted, and the other 2 models are predicting well. That is binary values only predicting. Whereas why this model is predicting wrongly, that is linear regression. I think we need to try it again. I'm just rerunning this cell, and let's rerun this to see whether. So again, it is predicting. I think there will be some mistake here for, yeah, since this is not a linear regression model, this is a logistic regression, right? So I need to take a logistic regression. Linear regression we actually use to predict, or we use it for regression based models, not for classification models. So that's the reason why we are getting the predicted value like that. So now we are taking logistic regression model. Okay. So now if we see the output, yeah, we just classification based output. So now if we see the accuracy, I'm just commenting this, the model and their model related accuracy. You can clearly observe logistic model is highly accurate compared to these 2. For this data set, I'm again stressing the point, For this data set, this logistic regression model is performing with high accurately. Let's say I want to see the confusion matrix as well, like how many positives, negatives, or how many predictions are predicting correctly, how many predictions are not predicting correctly. For that, we need to use confusion matrix. I'm just using this confusion matrix and again providing those two. So I'm printing in the next line, I'm printing the confusion matrix by providing the two inputs. What are the test value as well as the predicted value? I'm just passing these two. So first we need to provide what is the expected result and the predicted value. So like that in the same order we need to provide. The first one represents the total 0 0, nothing but. So in order to show you in a detailed manner, I'm just using pandas dot data frame of. So I'm just printing in the form of data frame. This 0 0 represents correctly predicting false values. You can see this is true negatives, and 1 1, that is this value represents true positives. So correctly predicted true positives and correctly predicted true negatives. Whereas these two values represents wrongly predicted values, that is true negatives and false negatives. So over all records, so these records like the combination of 125 plus 51 will be correctly predicted, whereas these will be wrongly predicted. So this is the confusion matrix, and by using this we can able to identify like true positives, like true negatives, that is this, and true positives, that is this, and false positives and false negatives also we can able to identify. So we have seen the accuracy as well as confusion matrix as well. Now let's see ROC, that is receiver operation characteristics. So that also we need to import from this sklearn dot matrix. I'm importing this ROC, so that actually present in the plot ROC cow. So by using this we can able to plot the ROC cow. I'm just taking the three models again. I want to plot the cow for each model, so that's why I'm taking each model and I'm writing this plot ROC cow, and then I'm providing the model name, the testing data set. So what is my testing data set? That also I'm providing, like x underscore test is the input data set and y underscore test is the expected output, right? Yes, so that I'm providing. Here, yeah, I'm using the model, right? So not only the linear regression, that is the model I'm using. So I'm just rerunning it. So there will be error, that is plot ROC cow. So this is not present. So I think we're getting some error. Yeah, we need to use from estimator. So that's the thing. We need to import ROC cow display method. So this is the method, not plot ROC cow display method. We need to import it. Then we need to take each and every model, and by using that ROC cow dot display dot from estimator, we need to provide our model and test data as well as testing features as well as output. Here you can observe for logistic regression. So area under cow you can see that is 0.84. Whereas for this decision tree classifier it is 0.72. For KNN it is 0.78. So how much more this area under cow is, that much accurate you will get the response. You can see if we have the cow like this, like towards this top left corner. So how much curve is towards your top left corner, that much good that model is performing. You can see it is a graph between true positive rates versus false positive rate. So among these also, by using this ROC curve also, we can able to classify that this logistic regression is working well based on this AUC value, area under curve. Based on this area under curve value also, we are specifying that logistic regression is working well for our data set. That is, we classified or we evaluated the models that we taken for this binary classification in this step. So based on these curves, we can able to tell that this is working well compared to other two based on AUC value. The AUC value is in between 0 to 1. If we get 1, that is a highly accurate or highly good model, best model. Ideally, that model is not possible. So we will use the model which is having the greatest AUC value. Since this logic regression is having high AUC, we will prefer that. So in this lab, what we have did is we taken the data set and we pre-processed that data set based on our requirement, and we considered the data that what we require, and we split the data set into training and testing, and we taken the binary classification related models, and we identified what model evaluation parameters we need to consider for evaluating the model, and we considered each and every evaluation parameter like accuracy score and confusion matrix. So based on that, we evaluated and considered which model is best, and we have also seen this ROC cow display based on area under the curve. We have classified which model is best. So I hope this video is useful to you and you understood these two concepts from this video. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye.